All right. Hello, Miss Yusuf. Hi, how are you doing? I decided to make this short video for you because you sent me a question on hypothesis testing. So, like, I can't answer that question for you because it is a homework question. So, I want you to answer it by yourself. Now, to help you out, I'm going to solve a similar question in this video so that you can look at that question and use it as a guide to answer the one that you sent to me. Now, look at the question that you sent to me here. Let me share this. This is the question you sent to me right here. This is it. It says, suppose a university advertises that its average class size is 28 or less. A student organization is concerned that the budget cuts have led to increased class sizes and would like to test this claim. A random sample of 42 classes was selected, and the average size was found to be at 1.1 students. Assume that the standard deviation for the class size at the college is 8 students. Use alpha 0.01. Using alpha equals 0.01, state the null hypothesis and alternative hypothesis. Then test the claim using the p-value method. So, like I said, this is the homework question, the one I want you to solve. Now, I'm going to solve a similar question, which is this one, to help you to be use it so that you can use it as a guide to solve the other question. The similar question is this. It says, suppose that a car manufacturer claims that their new hybrid car models has an average fuel efficiency of 50 miles per gallon or more. 50 miles per gallon or more. An environmental advocacy group is skeptical of this claim and want to investigate. They randomly selected 60 cars and found that the average fuel efficiency is 48.5 miles per gallon with a standard deviation of 4 miles per gallon. Use a significant level of 0.05 to test whether the manufacturer's claim is supported by the data. State not an alternative hypothesis, then test the claim using the p-value method. So I'm going to show you how to do this. You say using the p-value method. Now, before I would solve it, I will give you a hint on what the p-value method involves. A p-value method simply means the p-value means the probability value. So the steps involved here are as follows. First of all, you state the hypothesis and identify your claim. Then compute the test value. I will show you the formula to use that. Then find the p-value, make a decision, and then summarize. Now, the decision criteria under the p-value is this. If the p-value is less than the alpha, you reject null hypothesis. If the p-value is greater than alpha, you do not reject null hypothesis. That is the criteria for making decision for the p-value method. Now, having explained this, now let me solve this question. Solution. Okay, I hope you can see this. I hope you are seeing this. Okay, all right. So solution. Let's start by stating hypothesis, not hypothesis. Let me make it a little bit bigger. Make it 16. Okay. No hypothesis and alternative hypothesis H1. Okay. Now, because this is a test for the mean, it says average. The average, that means it's a test for mean. And they say that they claim that the average fuel efficiency is 50 miles per gallon or more. That means it means the symbol we're gonna use is be greater than or equal to symbol. Okay. So you have and the greater than or equal to symbol can only be used in the null hypothesis. So we have that the mean is greater than or equal to 50 miles per gallon. Why do we use greater than or equal to? Because it is, he says there that the average fuel efficiency is 50 miles per gallon or more. That means greater than or equal to. And that is the claim. Okay. The alternative hypothesis is always the opposite of the null hypothesis. So it's going to be that mean. So the opposite of this is will be less than or equal to. But the problem is that we cannot use the less than or equal to symbol in the alternative. We can only use that in the null. Less than or equal to symbol, greater than or equal to symbol are only used in null hypothesis. But what you can use in the alternative is less than or greater than. So that means the opposite, instead of using less than or equal to, here we're going to use only the less than symbol, which is this one here. 50 miles per gallon. So, and our alpha is 0.05. You can see right here, alpha is 0.05. I'll make sure I can see this. Make sure I see this. Yeah, alpha 0.05. So I'm going to put alpha equals 0.05. So that's the alpha. I'm going to correct it. Yeah. Alpha represents the significance level here for alpha. That means their chance of being wrong or committing type 1 error is 5%. So now we are ready to run the test. To run the test, we calculate the test statistic. And to do that, we list our numbers here. How many cars is selected? How many cars? 60 cars. And for that 60 cars, the sample mean is 48.5. I don't have the character for sample mean here, so I'm going to get it from the other book and then put it here. That's the X bar. So the sample mean, which is X bar, I'm going to get X bar, the X bar right here. So that X bar equals, I think they say that it is 48.5. 48.5. So our 48.5, 48. Okay, make it a little bit big so you can see it clearly. I'm gonna copy it and then paste it in our main workbook. Okay, for 8.5. Gonna okay, I'm gonna make it like this. Now I got a sample mean. So we're listing the numbers we need to that will be put in the formula. And population mean is 50 miles per gallon. That's mean. The population mean, sure I've seen this. Population mean equals 50. What else do we need? Standard deviation is 4 miles per gallon. Okay. The standard deviation. Our standard deviation is 4 miles per gallon. 4 miles per gallon. Okay. So now with this, we can now plug this into the formula to get the test statistics. After which we now get our p-value. Let me write this down. Okay. Yep. For 8.5 and 50, then standard deviation of 4, and n is 60. Okay, let's go and put this in the formula and then get our p-value. So the formula is z equals okay, let's see the equation. equals X bar okay minus mean, and our mean is given by this number here, divided by standard deviation, which is right here, over square root of n. That's the formula we use. So I'm doing it here so that because the other workbook will not allow us to put these characters. So when we finish, we copy it to that workbook, which is S bar is remember that from the other workbook is how S bar is 8.5 and mu is 50, n is 60. Standard, our standard deviation is 4. So plugging these numbers in, we're gonna have this. We're gonna have 24.8.5 minus 50 divided by standard deviation of 4 over the square root of n, which is 60. Okay. So when you go and plug this in our calculator, we'll go and put this in a calculator to get our answer. We have this. Okay. 48.5 minus mean of 50 divided by standard deviation of 4 over actually 4 divided by square root of n, and n is 60. Oh, excuse me, 60. So we get negative 2.90 as a result. Let me write it down. Negative 2.90. Okay, good. So we'll go and put it in our answer and then copy it to 2.90. Then copy it to our main workbook. We're almost done. This is just a very simple thing. I'm sure you are following up. This is our result. Okay, 2.90. Now we're ready to find the p-value. To find the p-value, so p-value now becomes, I'm gonna make this to be less bold. So make it 16. P-value now becomes, now to find it, first of all, we draw our chart. We draw our charts. Remember, our z is negative 2.90. So we're gonna have it negative 2.90. The middle number is 0. Okay, so that we can have this line. Okay. Oh, I think I choose the wrong line. Okay, let me see. I think I'm gonna undo it. So we have our p-value negative. Sorry, our z is negative 2.90. Then we got 0 here. So that inserts it's what I need right here. Okay. So I'm gonna make it black. Now I'm gonna choose this. So then I'm gonna put the center line. Then the 2.90 is right here. So you can see right it is. It's at the tail. See, it's at the tail. See, and I remember I told you that when it's at the tail, you will subtract the answer we'll get from the table from 0.5. So whenever it's at the tail, we subtract whatever answer we get from the standard number distribution table from 0.5. I believe you can see my screen. So I explained this in the class. So it's negative 2.9. The negative sign here is to show you that it's on the left side. Now, I remember I explained in the class, there are two types of table. The table in your homework is cumulative. I mean, nothing wrong with that, but I recommend that you use the table you are using in the class so that you can be getting correct answers. If you know how to use the table in the homework online, fine, you get some answer. But if you don't know how to use it, you'll be getting wrong answers. That is why I said in the class, stick to the table we are using in the class. And the table I gave you to use in the class is this one. It is not cumulative. So if you know how to use it, you still get the same answer. Okay. Now, in this case, our Z is negative 2.90. And like I said, I told you in the class that if it's on the tail, you subtract any answer you get from the table from 0.5. Why? Because half of this is 0.5 and this half is 0.5. So if you're looking only for this portion, you're going to subtract it from 0.5. So you got 0.5 minus, why do you write 0.5000? Because when you look at the table, all the numbers there have 4 figures. See, they all have 4 figures. So to make sure that it's have 4, those zeros we have here are merely placeholders. So let's look for negative 2.90. Remember the negative sign. If you're using this table, don't worry about the negative sign, because if you're using this table, the negative sign is only means that it's on the left side. So 2.9, just look for 2.9. Don't look for negative 2.9. Just look for 2.9. If you're using this table, and they have already shown you that negative sign means that it's on the left side. So let's look up for 2.9 on the table. 2.9, see Z. 2.9 is right here, and it's right. See the result 2.90, which is under 0. See, is 0.4981. 0.4981. So let's go and put it 0.4981. 0.4981. So 0.4981, that will give you, let's go and check it on the calculator. Okay, we have, that is 0.5 minus 0.4981. 0.0019. So 0.0019. And that will give that's the answer. That's a p-value right there. So now we're ready to make decision. Okay. Okay, now we have the alpha. Alpha is 0.05. Okay. Alpha is 0.05. Our p-value, okay, our alpha 0.05, our p-value is here 0.0019. So you have 0. And when you compare that, you can see that the alpha, our p-value is less than alpha. Remember, it says here, if the p-value is less than or equal to alpha, reject no hypothesis. But if it's greater, do not reject. So here, our p-value here is less than alpha. So we will reject the null hypothesis since the p-value of 0.0019 is less than the alpha of 0.05. So that means we are rejecting this one here. We're rejecting this. Okay. So we are rejecting it, the claim. That means if you reject this, that means we're accepting the alternative. So that means our conclusion now will become that our conclusion so that there is, since we rejected this, since we rejected the null hypothesis, that means that there is not enough evidence to support the claim. So there is not enough evidence to support the claim that the manufacturer's new hybrid car model has an average fuel efficiency of 50 miles per gallon. Okay. There is insufficient evidence to support. I gotta make this sense to be less bold. Support the manufacturer's claim that their new hybrid car model has an average fuel efficiency of 50 miles per gallon. So that is it. You state the hypothesis, identify your claim, your alpha, calculate your test statistics using this formula here, then find the p-value, draw a chart, then compare the p-values. If it's less than the alpha, you reject. If it's more than the alpha, you don't reject. Then you conclude. I hope this video will help you to understand this. So now use it as a guide to solve the equation. This is the equation here. Okay. All right. So I will say, I guess I will say, have fun. Bye-bye.